Alright. Here is the reservoir, which has an outlet at the bottom, which is I'd say about that big of a hole that is a circle, perfectly circular, and a smooth exit also. The water is being ejected from while it's constantly being pumped in from the top here by a sink at a constant rate. Currently, the flow is going into the bottle at the same rate that it is leaving. In addition, the pressure gradient necessary to achieve that flow rate is represented by the depth of the water in the bottle, which is the static pressure. So, if the flow speed is increased per pressure gradient, then the static pressure will lower until the flow rate becomes the same. And if it has the same flow rate at a lower static pressure, then it will have a greater flow rate at the same static pressure. In the process, the speed of the flow going into the bottle is not going to be changed. Alright, so I'm going to attach this diffuser, which has an expanded side here and a constricted side here. I'm going to attach it with the constricted side into the hole, so that the expanded side is the outlet, the constricted side is the inlet. And the first thing that we're going to see is how it affects the static pressure in the bottle, in other words, the depth of the fluid in the bottle. And by seeing such, we're going to see the difference in the necessary pressure gradient in order to achieve the same flow rate, because it will leave the bottle at the same rate once there's equilibrium between the water coming in the bottle and out.
So let's set down the camera and attach the diffuser. You see, the diffuser is attached to the hole that was previously there. Now I'm going to remove the diffuser. You see the diffuser is still attached. So now I'm going to remove the diffuser, and it's reverting to the open outlet it had before. You can see that the static pressure, represented by the depth of the fluid in the jug, is raising quickly. That means that it takes a higher pressure gradient in order to reach the same flow rate, because the flow that is leaving the bottle must necessarily be the same as the flow that is entering it. Alright, now what we're going to see is whether or not the attachment of a straight, non-diffusing length of tube that has the same diameter as the inlet of the diffuser into the hole on the reservoir that is ejecting fluid. We're going to see whether or not it being done so in the same manner as the diffuser also increases the flow rate per pressure gradient. In other words, I'm going to put it into the exit of the reservoir there, and we're going to see if the water in this jug goes down just like it did with the diffuser. Okay, it's in the hole, ejecting the water. no, the water level is not going down, the water level is going up. And if I remove, in fact it's going to overflow, I think. But what I was going to say is if I remove this, the water level will go back down. Yeah, if I remove it, now the water level is going down quickly. Now this tube has no constrictions in it, as you can see. It's completely empty, smooth tube of the same outer diameter as this. In fact, the diffuser has a smaller inner diameter. So adding a length of tube there does not cause the effect as adding the diffuser. Alright, but what if the length of tube that we added was very long? Let's test the theory that putting by the way, as you can see, it's completely clear, unobstructed tube, no constrictions or expansion, no diffusion. We're going to just put it into that same hole. We're going to see if it changes the flow rate noticeably. And yes, it is. It is slowing down the flow just like the last tube. And it is also about to make the water overflow the bottle. Despite the fact that this is hanging down quite a bit. And some people would theorize that this hanging down is increasing the flow rate in the bottle and causing low pressure in this region. Which it essentially is not. And no matter how low I put this, it's not going to create a fast flow in the bottle, and it's not going to create a low pressure in this area. But then right here, I just take this short diffuser and I'm going to insert it into that hole and watch as the water races back down. You hear the sound it's making? You see the water level going down a lot. Completely not related to it being a tube hanging downward from the exit of the reservoir.